The recording is pending. Okay, I think it has started now.
Yes, ma'am.
All right. So what is big data? I've explained everything, and most times big data is usually unstructured. However, we have different kinds of big data. We have the structured ones, the unstructured ones, and all. But different kinds of data rather. But majorly, big data is usually unstructured. And then like I said, big data, every second you generate big data. You know, people make payments with their ATM cards. Every hour, somebody buys something at the store. Millions of people use Twitter daily. Millions of people use Facebook daily. Millions of people use Instagram. All of these pictures, videos, images that are being posted, all of these things are volumes and volumes of data. And then how do you process such data? If I wanted to know how many people on Twitter are talking about a particular thing at a particular point in time, do I have to start counting them one after the other? No. So I have this large size of large number of people, and I just want to extract an aspect of this data. So this is what brings us to the study of big data, right? So and then as this data keeps getting generated, we need to be more organized. We need to be able to analyze it for the purpose of making business decisions. So that is why that's the reason for the study of big data. So now we have different classes of data. Like as you can see here. Oh, okay. All right. So like you can see here, we have the classes of data. Data is classified, big data rather. It's classified in terms of volume, variety, and velocity. So volume is in form of terabytes. Could be in form of terabytes. It could be hexabytes. It could be gigabytes. So volume just simply deals with how large your data is. How many records do I have? How many transactions have I made today? So that's simply what big data is. Volume is. Volume of big data is. Now for variety. Variety means the various types of the various places we can get data from. So it could be internal, it could be external, it could be social. So it could be social media, it could be from social media, it could be internal. Internal will be within a business organization, maybe within a business or within an organization, that's internal. And then we also have velocity. So velocity is how much of this data is coming in at a particular point in time. How fast is it coming in? So real-time data comes in every day. You know, just like as people post stuff on social media, that is real time. So real time is the rate at which it comes in every day or every second. Is it every minute? Is it every second? So that's what velocity is. And then, like I said already, big data is usually unstructured and qualitative in nature. So qualitative, not quantitative. Quantitative, you can't count. It is massive. It is massive. And then you can only say, okay, this is the kind of data that is being generated. But then it is big. It is extremely big. So most of the time it's unstructured. So that's basically what big data is about. And then the significance of big data cannot be put aside because without data, we cannot make informative decisions. So big data is very significant in our everyday life. So just move on to the next. So now we have advantages of big data. Now, big data helps with innovation. Without big data, there cannot be innovation because big data helps you get the information you need. And from this information, you can process it and make business decisions from inside. So big data helps with productivity and innovation. So now the various things that big data helps you to do, it helps you understand your target customers better. So I have a company or I have a business, and then I want to know which customers like blue colors more. I want to know why they like blue colors more. I want to know what I can do to make them like red colors more. Now, all I have to do is to gather data from probably sales. Probably I've been selling products over time, and I want to see, oh, which color do they like the most? Or who are the customers that like blue colors, and why do they like blue colors? Is it the customers from Lagos that like blue colors, or the customers from Port Harcourt that like blue colors more? So I can gather data on, I can gather my sales data. Sales data can be, I can gather it on location. I can have columns like location. I can have name of customer. I can have probably customer preference. I can have different things in my data set. And from this data set, I can be able to say, okay, I have 30% of customers that like blue colors. And I can say, okay, these blue colors, out of the 30% of customers that like blue colors, 20% of them are from Lagos, which means that majority of customers from customers that like blue colors are from Lagos. So I can make informative decisions from my data to understand my target customers better, to know whether, oh, okay, to be able to make more customers in Lagos like this color, I have to do this or I have to do that. So it helps me understand my target customers better. Then it also helps in cutting down on expenditures in various sectors. In sectors like healthcare, in sectors like retail, it helps me cut down expenditures. So for example, I was putting money into making customers like black color. And then these customers are they just like blue. So I would know that, okay, there is no need to buy black colors anymore, black colored clothes anymore. Let me just buy blue colored clothes, because I know that majority of my customers like blue colored clothes, instead of wasting so much money on buying black colored clothes. So it helps me cut down expenditures in retail, in sales, and even in the healthcare sector. You know what your customers want. And when you know what your customers want, you can cut down expenditures in return. So it also helps in improvement. You can also improve operations. You can know which of the machineries are deficient at any point in time, because you have information, you have real-time information. You can have a place where you have so many machines, and then you cannot monitor each of these machines, but you have probably a platform that gathers all of the information from these different machines into one space, and then I can easily say, oh, this machine is down at this point in time. I can see the information real time and say, okay, I need someone to fix this right now. But if I didn't have all of this data gathered in one place, I would not be able to easily say, okay, so machine is faulty at this point in time, and I wouldn't be able to get someone on time to be able to attend to that particular machine. So it increases operational efficiency, because I can understand what is going on in my company at any particular point in time. So it also helps in improving science and research. It helps in improving security and law enforcement. I was talking about an example some time ago. I was saying that I could okay, it was myself and my boss that were talking about it. So it was I gave an example of security. I was saying that, okay, for example, I want to be able to monitor people in a particular area. All I have to do is just to put a camera, and then the camera just tells me, okay, this person passed this place at this particular point in time, or this person was passing this place at this particular point in time yesterday, and it's passing the same place today. So that person might be somebody I should be suspecting, because normally that person doesn't pass that place at that particular point in time. So why are you passing that place at this particular point in time today? So I could use it to monitor movements of people. My boss also gave an example where he said that probably there's a particular area in probably in my organization. I had some restricted areas. I have some restricted areas rather, and then my camera can easily know, or can easily tell me real time when somebody tries to go to that restricted area. So my camera takes the record of that person and sends me probably an email or an alert that somebody is going to that restricted area right now, or somebody is about to get into that restricted area at the moment. And then knowing that, my security is easily alerted, and I can easily go to that place immediately and prevent probably stealing or robbery or something. So big data is very, very important in security, and it's also important in trading. In trading, that is trading, buying of goods and services. It helps you make better decisions. So it is important in different sectors, and I've mentioned some of the sectors that big data is very important in. All right. So before I move on, I would like some people to tell me probably one or two aspects of big data that you think big data is advantageous in, where you think big data can be applied, and where you think it is advantageous in. So let me see. I'm going to call the next person on my list. OVA. OVA. So tell me one example of where you think big data can be very advantageous in.
Good afternoon. Thank you so far for the meeting. One place where big data can be added. I'd like to use my field as an example. I studied petroleum and gas engineering. And in my field, we deal with a whole lot of data, trying to understand the reservoir, trying to understand the structure of our wells and all of that. So there's also a whole lot of uncertainties, a whole lot of assumptions that is also done in the oil and gas industry. So basically, we have some seismic data where we use sound to understand where we could find oil and gas underneath the earth. So in a case such as this, if we could find a way to optimize the sort of data we get from our seismic operations or some other sort of data, we increase our level of confidence with regard reserves and location of reserves underneath the earth. I think that's what I have to say. I don't know if this domain is similar I don't know, welcoming to everyone, but I could use some other example if you don't mind.
All right, that is fine. Thank you very much. So oil and gas sector, yes, very well. Oil and gas sector, big data is very important. Oil and gas in oil and gas sector. Sorry about that. So yes, for example, you could easily there's this thing that they talk about pipelines and all. So you could have something that monitors pipelines. I don't know if I'm right. I don't know much about the oil and gas sector, that monitors pipelines and knows when a pipeline is probably faulty. So that could also work in the oil and gas sector. All right, so let me call somebody else to give me another aspect of big data. Iola Daniel. Daniel.
Okay, yes, thank you very much. Thank you very much, Ma. Another aspect of that big data can be used is okay. I'll give my field of study also, my marine biology. Okay, so the ocean is a very large, covers 71% of the Earth, and since it covers 71% of the Earth, it's almost impossible to track everything that happens on the ocean surface and the ocean depths. So, but what they do is they put sensors around at various locations around the world, and then they collect this data via satellites. Now, this data, because of the ocean is large, there's so many collection points around the world, millions, billions. They're tracking so many animals, tracking so many things. So, big data can be used here to actually find relationships between the various data that they're actually tracking at that point in time, because data is voluminous, it's large, and it has a large variety too. It's not just water, they're also tracking animals, they're tracking other things. So that's another good example of big data too.
All right. Thank you very much for that example. So awesome example. So we see that the importance of big data cannot be overemphasized, and the advantages of big data cannot be overemphasized. So big data is actually useful in virtually every aspect of human life. All right, so we'll just move on to the next thing. Okay, so this is just still telling us the importance of big data in organizations. So in organizations, procurement. So suppliers deliver products, right? So if your supplier, you want to know which supplier delivers products at the right time, or which supplier delivers the best product and delivers products efficiently. You want to know which supplier does that and all, and you want to know how. You want to know when the supplier delivers the product. You want to know the kind of product and all of it. So in procurement, big data could be very useful. Also in product development. So you want to know what is in demand in the market today. You want to be innovative. You don't want to be on the spot. You want to know that, okay, I've been dealing in this product and then I want to still make sales. So what can I do to this particular product that will make it sellable in the market today? That is product development. So you're developing your product, and then in product development, you need data to be able to understand what is going on in your market at any point in time. So that is for product development. And then in manufacturing, you can use it to identify. I talked about manufacturing already. I was saying that you can identify machineries or processes that are faulty or that have quality problems real time. So you don't have to visit. Imagine you have a very big organization, and then yes, you have people that are in charge of machinery, but then these people cannot always be they cannot always be on their feet. They cannot always monitor it real time. But you can have a system that monitors this and just gives you data real time. So probably when you see null, immediately you see NULL, you know that this machine is faulty. Or when you see a particular color, you know that this machine is faulty, and then you just have to visit what particular machine is faulty. So that is one of the applications of big data in manufacturing, and also in distribution. So in distribution, it helps you enhance supply chain activities. So in supplying, you want to know your inventory level, or you've been storing a lot of goods. You want to know that, okay, so far we've taken 30% of goods A, and then 20% of goods A went into store A, 10% of goods A went into store B, and the rest went into store C. So all of this monitoring is also big data. You can also use it in marketing. You can use it to find out what marketing campaigns are more effective. So you are marketing a product, and then you are using different marketing approaches. You are using, probably one you're using billboards, and another one you're using flyers, and another one you're using social media, say you're using Facebook, another one you're using emails. So you want to be able to gather all of this information and see which of these campaigns are most effective. It is big data. It is still big data, because you gather this data, you are like, okay, so far from this data, I can deduce that people that pass this area are the ones that buy my product more. So that means if they pass this area and they buy my product more, that means it's a billboard that does majority of the campaigning for me, or it's a billboard that brings most of my sales. So it could also be used in marketing to know what campaigns are best for you. Also, it could be used in price management, merchandising, sales, store operations, and human resources. All of these things are things that you can check up yourself. There are so many applications of big data. We cannot talk about all of them, but we'll just talk about the few that we have here. So let us move to the next slide for the next aspect. All right. So now, various sources of big data. So we have different sources of big data. Like I said, data comes from various sources, and most of these data are unstructured. Like you have them from social media, you have them from transactions occurring daily on the ATM, when you are buying clothes, and so on and so forth. So sources of big data can be you can categorize big data into three aspects based on their source. So we have social data, machine data, and transactional data. Now, social data provides insight into companies about customer behavior and buying patterns, right? So, for example, you want to know. Let me see. Okay, for example, I want to go to Facebook, and I want to see people that buy my product more from Facebook. So, for example, I put up an advert on Facebook for my product, and then I want to know the number of people that maybe visited that site. Those that visited the site from Facebook, those that got to the page where where you would check out the product you like, those that got to the page where you would actually buy the product, and those that got to the payment stage. So from Facebook, I could get an insight into all of this, because from Facebook I can trace their movement. So it can help you provide insights into what consumers want, into their buying patterns. You can see that, oh, okay, I think most of the time when they get to my sales page, they just turn back. Why did they turn back? I can say, okay, that means my sales page has to my sales page has to be improved, right? So you can also do that from LinkedIn, Twitter, and the rest of them. And then sometimes on social media, you want to see the amount of people talking about a particular thing. So for example, there's probably a kind of, okay, maybe let's say a kind of product is trending on the internet currently. You can easily go to Twitter and see why this product is trending. You can check the kind of people that are buying this product, why they are buying it, and so on and so forth. So that is one use of social data. Social data, most of the time, social data is very useful because it makes you know there are different categories of people on social media, and from social media you can know which age range is buying this kind of product, or which age range is interested in this kind of product, and so on. So you can also integrate it into CRM. CRM is customer relationship management, for analysis of customer behavior. So like I already explained, that you can see how your customer is behaving. You can see what your customer wants from social data. So, and social data, we all know what social data is: Facebook, Twitter, LinkedIn, and the rest of them, Instagram, and all. So that is what social data is. So we also have machine data. So machine data majorly is from RFID readings. So, and who knows what RFID is, first of all? I want to be sure that everybody's following. Marvelous. Can you tell me what RFID is? RFID tags. What are RFID tags? Can you explain what RFID is?
I have no idea actually. I have no idea.
Okay.
Yeah.
Okay. Okay. All right. That's fine. Does anybody know? The first person to talk should just answer. Does
I
anybody
think
know
it's
what RFID chip?
radio frequency identification.
Okay, radio frequency identification. Right, you're right. So radio frequency identification is a type of tracking system, and it majorly uses barcodes to track and identify items. So it's like it uses a barcode to be able to track items. So you know that, okay, this item is going to this particular location, and all. So it uses location data to help you read what items are available, what items not available. It would also help you read your store levels. So you can use it to check your inventory. You can know that, okay, we've taken this amount of product, and then we need this number of products. So you can also use it to read data into your inventory. So it can be real time, and then you can also use to track user behavior online. So RFID is a typical example of machine data. So it also helps. You can also use it to track and monitor machinery parts from sensors. So it helps you read into your machinery using sensors, and then helps you transmit data to a readable format. So that's what RFID is. You can check more on RFID and yes, and get more information about it. So that's basically what RFID. RFID majorly uses barcodes to read data. It uses barcodes to read items rather. So you can just scan your barcode and know that, okay, this particular number of items, you could use to count a particular number of items. You can use it to know how many of the items are still available in inventory, and so on and so forth. So that's what machine data does. And then we also have transactional data. Transactional data is what we all know. You're going into the store to buy shawarma or pizza, or you're going to a store to buy clothes, you're going to a store to buy glasses. all of these things are transactional data. Transactional data will collect your name, it collect your location, it collect the product you got, it will probably collect what again could you collect? It could collect your first name and last name. It will collect your date, the date you bought the product, the date you registered as a customer, and so on. It would also collect the price of the product, right? So that's an example of transactional data. So you could it's majorly used in retail. It's majorly used in retail. Like you can see, it said retail websites such as Amazon.com and Domino's Pizza chain. So it helps you track data transactions, majorly in business to customer and business to business relationships. So that's what transactional data is about. Any questions so far? Before I move on, if you have any questions, please let me know.
I'm sorry, please. I do not have a question, but I'd like to request to allow Okoli Ebube in because he has been having network issues for close to 1 hour.
Okay. Where is he? He's not here. Is he in the lobby? I can't find him.
Okay, I'll just confirm with him now.
Okay. All right, no problem. Once I see him, I would allow him. I'll allow him. I'll allow him in once I see him. So I think I should be given a notification when he comes. So when I see him, I would allow him in. Thank you. All right. Okay, so moving on. All right, knowledge check. This has already been checked, but let's just go through. A manufacturing company needs to improve its sales in the coming year, but does not know how. It has sales transactions and customer databases. How do you think it can make use of this information? The company can make use of sales data to study the customer behavior and target them accordingly. The company can send coupons to all of its customers. The company cannot do anything with the data that it has. Very funny. The company should launch a new product. So this question is just trying to apply big data to a real life situation, telling us that a manufacturing company needs to improve its sales, but doesn't know how to improve it. And we have sales transaction and customer database. That is enough to be able to tell us what to do with our data. What to do. Like we already have we have sales transactions and customer bases. So all we have to do is to study these sales transactions and customer databases. And from these sales transaction and customer databases, we can say, okay, these are the kind of sales that will probably that we made. These are the kind of sales we made last year, and this is what we want to do in the coming year, so that we can have more sales. So, like option A is ticked. Option A is already ticked, and that is the correct answer. The company can make use of sales data to study customer behavior and target them accordingly. So the company can decide to target the customers that have been very active and see things that they can do to make them stay. The company can also decide to target customers that have been dormant for a short period of time and look for things to do to make them come back. And the company can decide that and say, okay, we are not targeting dormant customers at all. We just want the customers that are currently active. But all of this information is still going to be gotten from the sales transaction and customer databases. So linking the customers to the sales, you can see which customer has transacted in the last 2 months and which customer has not transacted in the past 1 year. You know that kind of customer is no longer interested in your company. So these are the kind of things that we can use sales and customer databases for. All right, so moving on. Evolution of big data. All right, so I'm actually following your textbook, and the slide, I'm sure the slide is very well related with your textbook, so you can just follow along. All right, evolution of big data. So the big data started a long time ago. a very long time ago. And then, like this slide is saying, in the early 60s, technology witnessed problems with velocity of real-time data. So there were problems already from this time, and they had problems with how much data comes in on a daily basis, in seconds, minutes, how much of data was generated. And so they decided that, okay, because of this number of data generated, we cannot continue analyzing this data manually. We have to put them in one place. And which one place did they decide that they will put them in? It was databases. So that's why today we have databases. We can say, okay, we have a sales database that has customers, products, transactions all in one. So that could be a database. And most times databases are structured, right? So in the early 60s, they already had problems with this. Now imagine what kind of problems we have today. If in the early 60s, we already had problems with velocity, with how much of data was generated. Now moving to the 90s, there were now problems of variety. So in the early 60s, there were no problems of variety. Now in the 90s, we had problems with variety. Now we had data coming from various sources: emails, documents, videos, images, social media postings, and so on. It was massive. And then because of this variety, they generated non-SQL stores. So we had to generate non-SQL stores, not just the ordinary databases. So places where you can store this variety of data, right? And then moving on to today, this technology now has issues relating to huge volume. Now we have so much of data now. So now the problem of variety is we don't have the problem of variety as much and the problem of velocity as much. Now the problem now is the volume. Now the data is now so huge, and then we need places to store this data. So we cannot let go of the data we had and put in the new data. We still have to store them because we have to go back to using them probably sometime soon. We have to see the things that have happened in the past to be able to see the things that are going to happen now and in the future. So now we need storage solutions that can store huge volumes of data, both in the past, future, and present. So now the need for this new storage and processing solution is the study of big data. So majorly, data can be classified into 3 V's: velocity, variety, and volume. But today, the major problem we have is volume. And that is why big data has become a theme in the 21st century. Everybody wants to move into big data because the topic big data is going nowhere very soon. It is something that all organizations use. All organizations want to understand their data. All organizations want to get information from their data. And they generate this huge data on a daily basis. So how do they do it? Sometimes you wonder how Google, how Facebook handle such volume of data. This is because they've been able to develop newer and better storage solutions and processing solutions. So that's about the evolution of big data. And then now moving to the evolution of big data technologies. All right, so before then, I want to quickly ask a question before moving to the next slide. Okay, evolution of big data technology. Okay, let's quickly do this before I ask the question. So evolution of big data technologies. So evolution of big data technologies helps business to enhance and streamline existing databases, add insights to existing opportunities, explore and exploit new opportunities, provide faster access to information, allow storage of large volumes of information, like I said, and allow faster crunching of data for better insight. So this volume of data cannot be crunched with the former technologies that we had. We need newer technologies. So these big data technologies are what help us to crunch data faster and help us to store large volumes of information. So it also helps us to add insights to opportunities. So we have different opportunities and we have so much of data, but how do we get meaning from this amount of data? That is why we need big data technologies. Also, it helps us provide fast access to information. So you need a particular information from thousands and thousands of data. It helps you extract needed information and provide insights from it very quickly. So that's why we need big data technology. So, all right. So the data chip, oh, this was the question I wanted to ask. So the question is, the answer is already there. Okay, let's just go through it together. So the data-driven approach to decision-making is not confined to only collecting data, but also to how the collected data is being used in making crucial decisions. The approach here is based mainly on data and its analysis. So you want to make decisions from your data, right? And they're telling us that it is not only confined to collecting data, but from this collected data, you want to be able to make decisions, which is decision making. Yes, providing insights from your data. So they are telling you that they're asking, what is this approach based on? Based on data and its analysis. So getting data and analyzing data helps you in making better decisions. So that's the question I wanted to ask. But we already have it answered here. So before we move on, does anyone have any questions? Please, any question? If you have any questions, kindly let me before I move on. Or any comments or any suggestions? Okay, if there are no questions or suggestions, someone should just say no questions, move on.
No question.
Okay. All right, no problem. Okay, so I'll just move on.
Yeah, thank you very much. Your explanations are quite clear. That's the reason why. Thank you.
Okay, you're welcome. All right, so moving on, structuring of big data. Right. So we can acquire data from two sources. And I would like to say these are the types of big data, right? So I would call these the types of big data. So the sources of big data, internal source and external source, I would like to call them the types of big data. So we have internal and external. Now, internal provides structured, organized data that originates from enterprise that helps run businesses. So internal sources of data are majorly data that come from within the organization. So the data that helps you run your business on a daily basis, the data that tells you that, oh, yesterday we had 20 transactions and day before yesterday we had 50 transactions. So in the last 1 week we had 1,000 transactions. This is the data that comes from within your business, and it is the one that helps you know that, okay, since we had 100 transactions last week or 1,000 transactions last week, most likely we would have around the same amount this week. So we need to check that our inventory still has 1,000 of our products, 1,000 products to be able to sell to our customers this week. So this data that helps you run your business on a day-to-day basis is data from internal source, right? So that's internal source of data. So it deals with a lot of things. We have product and sales data. That is the data from the product and sales, like I said just now. We have customer details. That is which customers are currently transacting, what time do they like transacting? Do they like transacting in the morning or in the afternoon? How much of goods would a customer probably buy on a normal day and things like that. So that's about internal sources. And for external sources are majorly unstructured data or unorganized data. And then they are usually gotten from places like the internet, like from market research. And these things help you to understand your competitors. So I want to know what to do to be able to be a champion. Let me use the word champion. I want to be able to be a champion in my sphere. So I'm in the agricultural sector, and I want to be somebody that provides most of the products used in my area. I want to be a champion in my sphere, so to say. So all I have to do is to check what my competitors are doing, right? And how do I check what my competitors are doing? I have to probably go to the internet to be able to check. I have to do market research to see, okay, what are my competitors doing that are different from the things I'm doing? What can I do to make myself become a champion in my sphere? So all of these things are external data. They are not from within the organization, but they also help you to provide good insights into business and help you make better business decisions. So that is external source. So data source, we have the examples of sources. Yeah, internal source, I said that already. Customer relationship management. You'll be able to know what your customer wants at any particular point in time and what your customers are beginning to like, what they do not like anymore, and so on and so forth. It also helps you in enterprise resource planning, ERP systems. Now, for external sources, I already explained that internet, business partners, data suppliers. You want to know, some people supply data. They supply data for you to study, so you know what to do. So these are syndicate data suppliers. And we also have the internet as another external source of data. So that is that about data sources. All right, give me a minute, please. All right, I'm back. Sorry for the short break. So yes, that's that about data sources. So moving on, we have types of big data. Oh, okay. So we can call this the types of big data and that the source of big data. And we have the categories of big data. So we have three different things now. We have the categories of big data, or will I say what big data comprises. So big data comprises volume, volume, velocity, and variety. These are the three V's of big data, right? So we also have the sources of big data, which is internal and external sources. And now we have the types of big data. So, so big data comprises volumes of data collected from varied sources. Yeah, I said that. So we have data collected from varied sources, and these different types of data can be classified, can be brought into three types. So we have three types of this big data. This big data that is gotten from various sources. We have three types of it. We have the structured, we have unstructured, and we have the semi-structured. And all of this makes up the big data. And so very quickly, I'll explain what structured data is. Let me see if there's something on that. Oh, okay, cool. I just wanted to say it from my head. So since we have it on the slide, all right. So for structured data, most of us know what structured data is. Most of us use structured data. Actually, most of us are very familiar with analyzing structured data. One way or the other, we've entered structured data into an Excel sheet, or we've used them, done data in CSV format, or entered into Excel sheets, or into Access, or into databases. So one way or the other, we've used structured data to provide insights. And even if we've not to provide insights, we've entered it, or we've dealt with it, or used it at one point in time. So structured data are usually organized. They have a repeating pattern, and they have fixed fields within a record. So for structured data now, we can see that we have the customer ID, we have the name, we have product ID, city, and state. Now, this particular table will also be related to another table called the product table. Now, the product table, we have this same product ID with products that are, with products that are related to each of these IDs. So say 241 would mean bags, and 365 could mean clothes, and then 421 could mean shoes, something like that. So anywhere you see 241, you know you're referring to bags and so on. So we could have another table that is called the product table. So this could be called a particular kind of table, and so on. So all of these kind of tables with IDs, well structured, one entry, one record per row. I'm sorry, I mean one row is for one record, and then the second row is for another record, and then the third row is for another record. And we have columns that break down these particular records. Any data in this form is called the structured data. And so, like you can see here, structured data has a format on which the entities and their attributes are mapped. So we can see that 12365 is the customer ID for this particular person, and this particular person bought this particular product. Then we can now check up the product table to see what 241 means. What 241 means as a product. Is from city grass, and then it's from state Syria. So they are mapped to one another. So structured data allows querying and reporting. So you can easily query this. I can easily say, I want to know all the customers that are from Wolfsburg. That is very easy for me. So if I had a longer table, I could easily use that without so much effort. So some sources for structured data are relational databases, flat files like CSV files, multidimensional databases, and legacy databases. So basically, databases help you organize your data in a structured format. So that is about structured data. All right. So very quickly, let's move to the next slide, which is unstructured data. Okay. So unstructured data. Unstructured data. So unstructured data usually contains a lot of metadata. That is data about data. And let me see if there's an example here. I'm able to show us. Oh, it is not here. I'd have preferred to show us what we mean by metadata. That is data about data. How do I show us something like that? Okay. All right. So metadata basically is it's telling you that it's relating a lot of data to one another. I would prefer to show a picture of it. So maybe next class I would show us what I mean by metadata, because I would not be able to say it, like explain it. It will be better explained with a picture. So we can check what metadata is, and then I can also come to next class to show us what the metadata looks like. So it is not consistent across different records, and it can be from emails, text, audio, video, or image files. So I've said this already. You have data coming from emails, you have data coming from text, audio, video, and so on. So this data coming from, you can't put data coming from images into a structured format. So it's just unstructured. Or you can't put data coming from emails into a structured format. It's unstructured because you have volumes of text. You have a lot of text and audio and video and so on. So this data is unstructured. And then most of the time, the sources of this data are from emails, probably emails transmitted between staff in an organization. It could also be data from social media, like your Twitter, LinkedIn, Facebook data. This data is massive and it's unstructured. You can't put it in columns and rows. So structured data is usually in a record file format in columns and rows, but unstructured data is not. It is just, most of the time it is so much of text or so much of words put together, or data from RFID tags, like I said already, data from barcodes and so on. So that is what unstructured data is. It could also be mobile data from text messages and location information. So GPS data is also an example of unstructured data. So GPS data is also an example of unstructured data. Global positioning system data. So the data to track your vehicles, to track weather conditions, and so on. Those data are called unstructured data. All right. So So the challenges of unstructured data. Now, we all know that unstructured data is usually messy. Let me use that word. You cannot deduce information directly as you would in structured data. Structured data helps you quickly deduce information. You can easily get insights from structured data. By plotting, you just need to plot probably a bar chart that shows you which has more frequency or so on and so on, or a pie chart that shows you, okay, this is more present than this. But for unstructured data, it's usually a daunting task to derive information from it. And so a lot of time and cost is usually involved in storing unstructured data. So of course, structured data is easier to get insights from than unstructured data is. All right, any questions so far? Any questions? Okay, so let me quickly ask. Let me quickly ask a question. Marvel, no, I'm not called Marvelous. Oh no, I'm not called Marvelous. So Marvelous, give me an example of unstructured data. Marvelous, an example of unstructured data. Any example of unstructured data?
Okay. Like you mentioned data gotten from weather forecasts and global positioning system. We also have those that we have from images and videos.
Okay.
Can you hear me?
You don't have
Okay.
any example different from the ones I've given?
No, ma.
Okay. Any other person has a different example of unstructured data? Does anybody have an example of unstructured data? Marvelous. Thank you very much. Okay, Iola.
Okay. I like to add tweets. Tweets from particular user could be also next as unstructured data.
Okay.
So yes, not just tweets, media feeds from particular user. You can actually work on that as unstructured data.
Okay. All right. Thank you very much, Iola. So it said tweets from particular user can be called an unstructured data, right? So you can say, I want to see tweets from this particular user, and tweets from this particular user will be an unstructured data. Iola, you can drop your hand. So and from this particular user, I can say, oh, I can even determine that this particular user is a fraudster or not, or it could be a fraudster. I could do that by looking at the kind of tweets he generates on a daily basis. I can say, oh, most of the words he uses are bad words, or words that target that majorly interprets the fact that he's probably in fraud or is doing fraudulent things and so on. So analyzing such data is analyzing an unstructured data, because I have to pull out words, the kind of words he uses on a daily basis, and see if these words are things that are related to fraud. And I could even bring him up and tell and say, oh, there's a 20%, I could predict that 20% of his tweets look like fraudulent tweets, and then it should be checked. So I could use unstructured data to know people that are into fraud, those that are related to people that are into fraud, and I could use it on and on and on to do a lot of things. So unstructured data is very useful, but then it is not structured, as the name implies, and then it requires much more effort. Imagine I want to analyze such a thing. I have to extract all of these words. And if he has been tweeting for the past 10 years, I have to extract all of these words to be able to see the patterns and to be able to determine that, oh, I can assure you that 50% he is going to be a fraudster or he's not going to be a fraudster. So that's analyzing unstructured data. And then unstructured data, of course, like I said, takes more time it takes more time for you to get business decisions, to be able to make business decisions from unstructured data, unlike structured data. So yeah, so continuing it, whereas we can see the following graph shows leading unstructured data challenges in percentage from the most challenging to the least challenging. So the most challenging data growth, like I said, volume of data. So volume of data, the volume of data increases on a daily basis. Like we have more and more and more data coming out on a daily basis. So data growth is most challenging. And then we can see that followed by data infrastructure and data integration. Now, the infrastructures of data, the infrastructures for data and integration of data too, it's growing on a daily basis. It is challenging, it's becoming challenging. At some point, I fear that we might not even have the right infrastructures to be able to hold our data together. So that is how much challenging it's getting on a daily basis. And then we can see data governance. We have a lot of we can't protect our data. Sometimes our data is wrong. We cannot be sure that our data is correct 100% of the time. So that's becoming very challenging because we have so much of data. So ensuring that we are generating the right data and using the right data is becoming very challenging. Then velocity and variety is becoming more challenging, and so on. So that is that about that. So let's move to the next slide, which is the last slide. So we want to check our knowledge. ABC is a retailer organization that conducts its business through e-commerce. So ABC is a retailer organization that conducts its business through e-commerce. The organization offers customized online shopping experience to its customers with an attractive and responsive web page user interface. Now, the company wants to collect the data about customer activities on the internet. What can be the best source for such data? So a retailer organization conducts its business through e-commerce. That is, it sells its product online. And the organization offers customized online shopping experience. How does it do this? It uses a very beautiful and responsive UI. So the UI of the page of the online shopping page is very responsive and attractive. Now, the company now wants to collect data about customer activities on the internet. The company wants to see what the customers are doing on the internet. What can be the best source for such data? It is the transactions. The transactions occurring. So you can see this customer bought this particular product at this particular time. So it is the transaction data that you would use, because you want to collect data about customer activities. You want to see what the customer is buying, what time the customer is buying it, and so on. So data about customer activities is transactional. So it is transactional database that will give you that kind of information. All right. So that's about introduction to data for the first part. And so for the second part, all right. So let's quickly check this. What do you think could be the biggest challenge for the production or operations unit of an organization? What do you think could be the biggest challenge for the production or operations unit of an organization? Now, determining the data to be used for making business decisions, determining the best big data technology to be used, securing big data initiatives from unauthorized access, no. Determining the best way to present big data findings to enable decision making. What do you think would be the biggest challenge for the production or operations unit of an organization? So a unit in an organization produces and is in charge of operations. What could be their biggest challenge? It cannot be securing big data initiatives from unauthorized access. That is not their business. That is not their business. We are dealing with production, right? We're dealing with operations. We want to know what to produce next. We want to know how to produce it. We want to know how much of this to produce. It cannot be determining the best big data technology to be used. It cannot be determining the best way to present big data findings. Their challenge could be determining the data to be used for making business decisions. So they want to know, okay, we want to know what to produce, how to produce it, when to produce it. It's the data for making business decisions that they'll probably be working on. And that could be their challenge. So that is for knowledge check 4. So now we'll move to the third type of data, which is semi-structured data. Now, semi-structured data is also called, you could also call it schemaless or self-describing structure. And it's a form of data that usually contains markup tags or markup elements. So it's like structured data, but then it is not completely organized into a structured data format. It self-describes itself, and I will show us an example of that. It self-describes itself. So most of the time, it's data in form of XML, that is extensible markup language, and then it is usually a bit more complex than structured data. So you can check what XML means, which is extensive markup language, and then it doesn't arrange your data completely into columns and rows. It uses tags, so it tells you this means this and this means this. I'm going to show you in the example that is going to be probably going to be on the next slide. I hope it's on the next slide. So some of sources for this semi-structured data are database systems. You could get them from database systems. You could get them from the web. You could also get them from scientific data. So it's in the middle. It is not structured and it's not structured. It is just in the middle. So most of the time, you can convert semi-structured to structured. You can arrange your data properly and make it structured. So let me see if we have the example on the next slide. Oh no, we do not. Okay. So for example, let me just describe it with my mouth. So we have, for example, you have serial number 1 and 2, and then you have the name of a person. The name, you have the serial number column, right? Then you have the name column. And in your name column, wait, do you all have your textbooks with you? Oh, someone is raising up his
We
hand.
don't have textbooks yet.
We don't have the textbooks yet, though.
Okay. Someone is raising up his hand. Do you want to say something?
Yes.
A date or
The last question. The first and last option seems similar to me, so I wanted you to please explain the difference.
Which one?
The last question we answered.
Oh, the last question. Okay.
I think the previous slide, yes.
Okay.
So to be used and the last option.
And last option, determining the data to be used for making business decisions. Now, let's look quickly at this. What do you think a production unit is looking for? A production unit is probably looking for, okay, if I were in the production unit, what will I be thinking? I'll be thinking, okay, what next will I produce? How should I produce it? Should I brand it with a lighter color? Should I brand it with a darker color? How do I know what customers will want now? Okay, we've been producing it this way, we're producing this number of products. Should we produce more? Should we produce less? And all. That's what I'll be looking at. So determining the best way to present big data findings to enable decision making. Now, this option is telling me that what should I use to present my big data findings? Should I use Power BI, or should I write it? Should I write it in form of text, or should I explain it with my mouth? So determining the best way to present big data findings should not be a problem.
Right.
They don't need that. They don't need to they don't need to rack their heads around determining how to present their big data findings. What they need to do is to be able to make decisions, to be able to improve the production unit in the organization.
Yes,
Do you
ma'am.
understand?
Yes, ma'am.
Exactly.
Thank you very
Yeah.
much.
Okay. So that's why it's option A. All right. So moving on, semi-structured data. Yes. So I was talking about semi-structured data. Okay. Please, a minute, please. All right. So I was talking about semi-structured data. So I was saying that if you have columns, for example, you have column 1, which shows you the serial number, yes, and then we have column 2, which shows you name. The name of the column the name of the column is name, right? And we have a third column. The name of the column is email. Now, for name column, for example, in name column, we now have under name column for serial number 1, which is the first person. We now have first name and last name. First name, column, the first name of the person. Last name, column, the last name of the person. In just name for serial number 1. Now that is semi-structured. A structured data will have it as serial number, first name, last name, email. But a semi-structured data will probably have it as first name and last name occurring under name alone. So that is semi-structured. It would have it will not have everything in rows and columns. Sometimes you could see some columns, I mean colons, in a column, column. So in a column, in a column, I could have first name, last name, occurring under the same column, which is called name. So it's like you have multiple data under one column. So one column is supposed to represent one information, but now one column is representing two information at the same time. So it's a different thing if you told me full name and then I have Stephen Jacobs. Now that is understandable. But the moment where I have name and then under name I'm having for serial number 1, I'm having first name. For the same serial number 1 again, I have last name again. So that has breached my row, my serial number 1 into two rows. So I have row 1, first name, the name. I have last name again. That is semi-structured. So structured data will have just one element per row. One element per row and column. One element in a cell, not two elements in a cell. So that is semi-structured data. And it is not as straightforward as structured data is. So that's what I was saying, that you could convert your semi-structured data into structured data. So that is about semi-structured data. All right. So all right. So we're moving to the next thing, which is elements of big data. If you have any questions, please let me know. Let me see if anybody's raising up their hand. Okay, nobody's raising up their hand. All right. So let me just move on. Okay. So we have elements of big data. Oh, I already talked about this, the 3 V's of big data, which is volume, velocity, and variety. I already talked about this. And like I already said, volume is the amount of data generated in an organization or by an individual. The volume, the amount of data generated, that is what volume is. And now they're telling us volume is now in exabytes. Wow, that's a lot. Because we have MB, the MB, which is megabytes. Then we have gigabytes. Then we have 1,000 gigabytes giving us 1 terabyte. Then we have 1,000 terabytes giving us 1 petabyte. And now we have 1,000 petabytes giving us 1 exabyte. Now, they're telling us that the volume of data is now in exabytes. So, meaning that we would have so much more data as time goes on. So, that is what volume is. Volume is the massive amount of data. So, the quantity. So, you can measure it now. We can measure it in exabytes. So, that's the volume of data. Also, we have it in variety. Like I told us, velocity rather. Velocity is the speed at which your data is generated. So you could say data is generated. You can say 1,000 sales. We have 1,000 sales every hour, or we can say 1,000 gigabytes of data is generated per second. So that's the velocity. Velocity speed, which deals with time. How much of data is generated per time? That is what velocity is. Rate at which data is generated. Rate at which data is generated is velocity. And then we have variety. Variety, like I said, is different kinds of data that is generated from different sources. And we talked about these sources already. We said social media. We said can generate them from our from emails, from our mobile phones, from transactions, and so on. So that is variety. So those are the three V's of data, and they are also called the elements of data. All right. So very quickly, let me ask this question without going to the next slide. So I would like, okay, yes, please, Daniel Iola, Daniel.
Okay, thank you very much, Ma. Somewhere I read about big data having more than just three V's. Somewhere I read that they have it has volume, velocity, variety, veracity, and value.
Veracity. Okay.
I just wanted to confirm that if it's true, or these are just the basic three that used to classify big data. There's no really need.
What
I
do you
just
call
wanted
the
to know
last one? Veracity and what? What's the
value.
last one?
Value.
Value. Okay. So I would say from my own point of view, right? From my own point of view, I would say that this veracity, the three V's I mentioned are the major elements of big data, which is volume, which is variety, volume, variety, and velocity. Now, what is veracity? Veracity is like you are trying to see if it's accurate. You are trying to see if your data is factful, if your data is accurate, if you have to be concerned about the truthfulness of your data. Veracity is truthfulness, trying to know what whether your data is correct or wrong. That's what veracity is. Now, I wouldn't really say it's an element of big data. I can say it's one of the V's of big data, so to say, but I won't say it's an element. Elements more like categorizes. It helps to it's like categorizing your data, and I won't say veracity can be called an element. Veracity is just knowing whether your data is factful or not factful. That is what veracity is. So I wouldn't call it an element. I would say it could be part of the three V's, maybe not part of the major three, part of the V's rather, maybe not part of the major V's of data, but from the meaning, we can see that it doesn't particularly explain what big data is. It is only telling us that, okay, data could be truthful or not truthful, or it could be factual or not. So from my understanding of what veracity is, I wouldn't say it could be a major element of what big data is. And sorry, I'm coming, Hubert, I would answer you. Then value. Value is something that is of importance of what, right? I wouldn't also say that's an element of data. So I'll still stick to three elements of data, which is volume, variety, and velocity, which defines what big data is. So maybe in some textbooks, in some places, they could add those two, but then it doesn't particularly explain what big data comprises of. So big data comprises of three things, and these three things, I think, has encompassed what big data is as a whole. All right.
Thank you very much, Ma.
Yeah, you're welcome.
Yeah, thank you very much for breaking down this the three V's as you explained. You've really explained even more than expected. What I wanted to point out is that earlier on in the class you mentioned these things, velocity, volume, and variety as the classification of big data, and now it's elements of big data. Are you also saying that the classification is same as the element? And that's what I want to clarify that.
Oh, okay. Okay. All right. So I remember I mentioned that classification of big data. Yes, yes. Classification elements of big data. When you say something comprises of something, what does big data comprise of? Big data comprises of volume, variety, and value. It is classified based on this. Like you can classify big data based on this. It is also its elements. So when you can classify something into three different things, it is also the elements of those three different things. So I would say it's the same thing. Classifying it based, saying it's the classification, or saying it's the element, I'll say it's the same thing. I'll say it's the same thing, yes. So if you say if you are asked what can you classify big data into and what are the elements of big data, I will still say it is volume, variety, and velocity. Yeah.
All right. Thank you.
You're welcome. All right. So good addition, Daniel, veracity and value. That's a very good addition. But then, different textbooks have their different approaches to things. But sticking with the DASTA curriculum, we have three elements of data. From my own point of view, I'll stick to the three elements of data because they explain what big data is to me. Veracity just tells me whether my data is factful or not. Value just tells me whether my data is important. But volume, variety, and velocity explain what big data actually is. So I'll stick to DASTA curriculum, and then probably the textbooks will stick to what they believe is correct. But then it's good that we also know that there are also other 2 V's that are available, just in case you see it somewhere and they say, what are the 5 V's of big data? You can easily just add this other 2. But we all know the major 3 elements of big data. All right, moving on. So we've explained what volume, velocity, and variety is. So yeah, so knowledge check. Oh, no. Let me go back. So let me ask this question. I'll read it and let me see. Someone is going to answer this question. Richard. Yes, Richard. Okay, so Richard, I think I talked to Richard today already. Oh, okay, Richard replied me when I asked if everyone was around. Okay, so Richard, you're going to answer this question. With the enhancements in technology, companies are using different ways for marketing their products and services. With the enhancement in technology, companies are using different ways for marketing their products and services. The new sensors are being used with new marketing campaigns, and this results in new type of data and information. So we have new sensors which are being used with new marketing campaigns. So we are developing new marketing campaigns. And because of this, we now have new type of data and information. Which element of big data is being discussed here? Do you understand the question, Richard?
Can you come again, please?
You said?
Can you come again?
Okay, I should come again. So with the enhancements in technology, companies are now using different ways to market their products and services. So enhancements in technology has made companies use different ways to market their products and services. So what you were using before might not be what you're using now, right? So based on this, we now have new marketing campaigns. And this has resulted in new type of information and data. Which elements of big data is being discussed here? We know we discussed elements of big data. So which elements of big data is being discussed here? So from our three elements of big data, which element of big data do you think is being discussed here from the elements of big data you know?
Actually, you are breaking, but I'll go with variety. I don't know if you can repeat yourself for the last time, but you'll
go with.
Can you repeat yourself for the last time? I'm sorry.
Okay. All right. With the enhancement in technology, companies are using different ways for marketing their products and services. The new sensors are being used with new marketing campaigns, and this has resulted in new type of data and information. Which element of big data is being discussed here?
Variety.
Variety. Okay, I'll also go with variety. So let's see what this tells us. So this tells us velocity. Wow. So why is this telling us velocity? Is someone saying something?
Yes, I want to reply.
Okay. So why is it velocity?
Actually, looking at what they said technology is advancing and everything, and I think velocity also talks about the rate at which data changes over time, which is actually that's actually velocity, rate of change of time, or something like that. So actually, they actually have to move with the trend also, which is actually why I think the answer should be velocity.
Any other explanation to why it's velocity? Anybody? Okay. So so the truth is, looking at this question, variety actually answers this results in new types of data and information, right? But then looking at the question as a whole, with the enhancement in technology, companies are using different ways for marketing their products and services. Now, new sensors are being used with new marketing campaigns, and this has resulted in new types of data and information. Honestly speaking, variety answers the question better. But then you could also use velocity, because velocity has to do with the rate at which data is generated and captured, right? So if new sensors are being generated, that means we need to generate data. That means data is coming out faster. We have more data. We have much more data coming. So we have to develop new sensors. We have to use new sensors for this. So that has to do with velocity. But looking at the question, I will still probably shuffle between velocity and variety. But I would like somebody else to contribute to this particular question. So anybody else, tell me why we should choose velocity or variety. Okay, fullback.
Oh, okay.
Yeah, hello? Can you hear me?
Yeah, I'm here. I can hear you.
Okay, I'd like to say, I'm just adding, I don't really know, I've just add to it. Basically,
Yeah.
the trend which you showed when you're talking about the history of big data, it started out with volume, yeah, with
Yeah.
volume. And then from volume went to variety, from variety went to velocity. And when you talk about volume just talks about the quantity and the size and all of that. And then variety talks about different data structures and all of that. So as it goes ahead, I feel like the next stage is having the ability to conquer the previous stage. So volume can only conquer volume, but variety can conquer both volume and diversity in data. But then velocity talks about handling the rate at which the data is being generated. So velocity handles both variety and volume. Now, with regard this particular problem that's been discussed here, it says with the enhancement of technology, improvement of technology, companies are using different ways to in marketing their products and services. So that means they have products and services. Products and services could also fall under variety and volume. But now it says the new sensors are being used with new marketing campaigns. So that means new marketing campaigns means there are new things being generated. And this talks about velocity and generation of new data. This is the reason why this particular question comes in for velocity. Now, if you would go to select both volume and velocity, that wouldn't be right to choose because velocity already handles both volume and variety. So velocity, the further you go when it comes to the element, the stronger you handle your data. So that's the reason why I feel this particular question, the answer should be velocity. Thank you.
Okay. All right. So, okay. Okay, it's Hubert that is raising up his hand. Okay. So, well, from Hubert's explanation and from all the explanation, velocity actually is the rate at which data is generated, right? So I would say the reason for choosing velocity here is because we had to develop new sensors because of the rate at which data is being generated. So there's an enhancement in technology, and then there are now more ways to market your products and services. Now, because these new sensors are being generated, and because of this amount of data, we have to generate new sensors to be able to still go ahead with our marketing campaigns. Now, this now results in new types of data and information. So it's just the later part of the sentence that tells us that we have new types of data and information, right? The whole explanation tells us how much more of data we now have, which shows velocity. But then the later part of the sentence is explaining that, okay, we now have different types of data and information as a result of all of what has been discussed earlier. So if they say which element of big data is being discussed here, we didn't say what is the result of this question, or we didn't say just the conclusion in this question. We are talking about the question as a whole. We discussed something, and then we now said, okay, it's resulted in new types of data and information. So it is still velocity, which counters our first answer. So we have enhancements in technology, and then there are now so many other ways to market products and services. Because of these so many other ways, we have new sensors that are being used with new marketing campaigns. New sensors, new marketing campaigns. This is more data. This is more data being generated. And so because of this, we have real-time data coming in. We have much more data coming in. So we're describing velocity. We are describing how much more of data is coming in because of the enhancements in technology. So I would go with velocity, like this place went with velocity. So I would also go with velocity. But then towards the end, we see that it resulted in new types of data and information, which is not the concept being discussed. So that also teaches us something, that when we are answering a particular question, we should see the concept behind the question, not just the conclusion behind the question. So the conclusion behind the question was it resulted in new types of data and information, right? But the question as a whole is telling us why we had to develop new sensors. This is because of the rate at which data was generated. Why did we need more marketing campaigns? The rate at which data was being generated. Do we understand?
Yes, ma'am.
Yes, ma'am, we understand. Thank you.
Okay. So please, let's just try to look at the questions critically and then understand the question as a whole, and not just look at the end result of the question. Because I would also go with variety, looking at it. But then understanding the question better would make you know that they were actually explaining the rate at which data was now being generated, which resulted to them having to develop new sensors, having to use new sensors and bring up new marketing campaigns, which describes velocity. But then the result of this velocity is what brought about variety, right? But then velocity is the concept being described here, not the result of what happened in the question. So let's try to understand the questions well before we choose our answers. Okay, so next we would go to application of big data. All right, so application of big data is not very interactive. Our time is fast spent, and then I think that is the last thing for today. Application of big data. So there are different applications of big data. We can use it in education, in government, in healthcare, and so on. So very quickly, I would just like us to tell us the various applications of big data that we know. And then I'm going to just list two people's names to tell me that. Hubert, do you want to say something, or you're just raising up your hand?
Sorry, I forgot to drop my hand.
Okay. All right, that's fine. All right. So Sunday, can you tell me one application of big data in any sector? Mention the sector and mention the application. Sunday.
Sorry, we can use it in aviation.
In aviation. Okay. What in aviation can you use it for?
We can be using to track entries of actually okay customers entry. Okay, how many flight has been were we able to allocate today? And flight entries, customers entries, um, even the climate aspect of this. Another site can be
Okay,
for climate and
climate. Good, very good. So you can also use it to check weather. You can use it for
weather.
weather forecast.
Yeah.
Yeah. So you can use to check. Thank you very much, Sunday. You can use to check the weather at any particular point in time and see if it's okay to fly. You can use to check how many people are on the flight per time, how much of people have gone on the flight today, on a particular flight today, and so on. So, Tony, could you tell me one sector of big data application and how you can use it in that particular sector? Tony.
Hello.
Yeah.
Okay, you can use it in e-commerce.
Okay.
So
What can you use it for in e-commerce?
e-commerce is basically buying and selling on the internet. So you can use it to know for customer behavior now. Like if you open Jumia, so you can put the kind of products based on your search. You can use it in all those e-commerce sites so that you can know the products you will most likely buy, maybe based on your search or something.
All right, thank you. Can you pronounce your name?
Ibitamuno.
Ibitamuno.
Yeah.
Oh, yeah, Yoruba.
No, reverse.
But Ibitamuno is it Yoruba?
Reverse.
But it actually means something in Yoruba. Do you know that?
Nope.
Okay, don't worry. Go and ask a Yoruba person that what is the meaning of Ibitamuno? All right, Yoruba people understand what I'm trying to say. Okay, so all right, so those are the basic applications, and we all have mentioned some other sectors in, and we can apply big data in healthcare, education, and so on. You can know which students are performing well, why they're not performing well, why they're performing well, and so on. You can use it in healthcare to know which drugs are currently being used, which drugs are working for your patients, how much of patients come into your clinic daily, how much of patients recovered patients, patients that recover daily, patients that have stayed a longer time in the hospital, and so many other things. So big data analytics is applicable in almost all areas, almost all sectors of life. All right, so analytical approaches, we have predictive analytics. You can use it to predict what will happen. Let me not use predict. You can do forecast. You can have a set of data, and based on this set of data, you can say this is what is going to happen in the future. So it helps. You can use it for predictive analytics. You can use it for behavioral analytics. You can use it to see how a business is faring. What is happening with the business? Is the business doing well? Should we go ahead with this business? Are there challenges with the business and so on? You can also use it to interpret data. You can use it to know that, okay, from what we've discovered, we can now make these decisions. And these decisions can help for better business, better profits, and so on. So you can also use it for data interpretation. So, like I said, big data application areas, education, students' ability to comprehend, transportation, to know to see traffic. You use it indirectly. All of you check Google Maps, especially in Lagos. You like checking Google Maps so that you don't get stuck in traffic. I do that a lot, and I know every other person does it. So you want to check Google Map, you want to know if you should pass so route or not. You want to know whether you should move now or you should move later in the night. So I know Lagos people will like crawling in the night because that is when the road is free. So transportation, we also use it for travel and we also use it for government. So government use it to analyze risk and fraud most of the time. That's what governments use data for. Okay. So you are the marketing head of an organization. You plan to increase your market outreach by converting prospective customers to actual customers. Which of the following analysis approaches would you consider as the best to adopt? So you want to convert prospective customers to actual customers. It's behavioral analytics because you want to see why you have those customers and why you do not have these customers. You want to see what is the reason you have them. What is the reason you do not have this set of people? What do you need to change? You have to study their behavior. You have to study their buying pattern. You have to see that, okay, these prospective customers, this is what they like buying, but we do not always have this particular thing. Can we have them more often so that they become our actual customers? So you are trying to study their behavioral pattern. So that's what behavioral analytics is. You can also use it to study the behavior of your business. If your business, okay, still studying the behavior of business is studying the behavior of your customers. Because when you're studying the behavior of your business, you're trying to see what customers like and what they do not like, right? So, and then you want to see how well your business is faring based on what customers are saying. So it's still behavioral analytics. Okay, we have top companies hiring big data professionals. That is by today. And then professional opportunities in big data. So we all know there are different professional opportunities in big data. But for big data analytics, we have the data scientists, the data analysts, and the big data developer. So most of us are on the data analyst track. And then from data analyst, you can move on to becoming a data scientist. And then most times, a data scientist can do the job of a data analyst, right? But a data analyst is not always usually able to do the job of a data scientist. Because a data scientist actually makes decisions based on analyzed data. So he looks at the data that has been analyzed and recommend ways to improve your business for you. So a data scientist actually works like a scientist, someone that analyzes something, comes up with a theory, and then recommends ways for you to improve your data. But then, what does a data analyst do? A data analyst just collects, organizes, and analyzes data from various sources. It helps you gather data from various sources, and then give you the results, give you the visual or something. But a data analyst actually analyzes the data from different aspects. It goes deep into researching, into understanding the business domain, so that you'll be able to recommend better ways for you to improve your business. So from what a data scientist gives you, you can get better ways into improving your business because he actually does a lot of research. It doesn't just analyze data given to you. It does research on the data it's about to analyze and then gives you good information. A big data developer, in the other sense, designs what will I call it now? Databases. So it designs a database, it creates code, it designs your databases, it creates codes to manage your data, to interpret your data, and so on. So it organizes your data for you in a format that is readable. So I would say that a big data developer works hand in hand with a data analyst, and a data analyst works hand in hand with a data scientist. But a data analyst can always grow to become a data scientist. All right. So I think that's all for today. These are just the skills that a big data professional should be good at, or should be a professional in. And then these are things that you will learn as we go on in the business, in the data analytics class. For those in the data analytics class and for those on the engineering track, you will have there are some skills that you'll be learning, things like R, like Hadoop, understanding Hadoop, MapReduce, and so on. You might not learn all of it here, but you learn most of it, and you have an idea of most of the technical skills from this graduate training program. So soft skills, of course, you have to be able to interpret your data. I cannot be a data analyst and they ask me, okay, what do I mean by the visual I created, and then I cannot say anything about it. So I have to be able to communicate properly to be able to communicate to a layman, someone that doesn't understand what data is about. He just wants to know what to do. So how do I communicate what I've gotten to him? That is what a big data analyst should be able to do, a big data professional should be able to do. So I think that's basically all. This is just a summary. And this is just showing the growth in big data, the enormous growth in big data. You can see how much big data has grown over the years. Massive. So let's quickly look at this question, and then we'll call it a day. Sam is seeking a career as a data analyst. Which of these is a key responsibility of a data analyst? So determine what data means and recommend ways to search the data. Specialize in collecting data from different sources, organizing it in a suitable format, and making analysis. Design, create, manage, and interpret large data sets to achieve business goals. Develops codes and images to automate data reports. So a data analyst, like I told you, he determines what data means and recommend ways to search the data. Yes, from here. Specializes in collecting data from various sources, organizing it in a suitable format, and making analysis. Now, a data analyst, the key responsibility of a data analyst is to get this data, is to search the internet for the data. Okay, for example, not internet, I mean search for data that is usable. Specialize in collecting, organizing, and analyzing data from various resources. So, coming back to the question, determine what data means and recommend ways to search the data. Specialize in collecting data from different sources, organizing it in a suitable format, and making analysis. Now, this is the key responsibility. Its key responsibility is to search the data, is to search for the data, get what the data means, and then further, it can decide to make analysis. But what is its key responsibility? Its key responsibility is to do this, is to search, recommend ways to search the data, and then determine what this data means. So moving to this option B looks more like it, but then organizing the data in a suitable format and making analysis will be more of a data scientist's work. Analyzes the data from various angles, determines what it means, and recommends ways to apply the data. So as you can see, a data analyst does this more. It recommends ways to search the data more. So this particular part shows that this is a data analyst job, searching for the data. So sometimes you have to look critically into your answers to be able to determine the right answers. So when you see searching the data, that is a data analyst job. Now you can move on to do the rest of the things, but this shows that this is a data analyst work. It shows it more than option B shows it. Option B could also pass for a data analyst, but then searching for the data is the data analyst job. So the data analyst actually searches for the data. And then he also determines what the data means from searching for the data. So basically that is all. This just summarizes all we've learned today. And then if you have any questions, please let me know. Before I call it a day, we have spent 5 minutes past our time. So if you have any questions, just raise up your hand. So I'll quickly answer that, and then we'll call it a day. We've learned so much today. I'm sure our heads are very full because my head is also very full. I've been the one talking anyway. So everybody has just been listening. So if you have something to say, contributions, questions, please let me know. Okay. Who that?
I would like you to answer Ibitamuno first, please.
What did you say?
I would like Ibitamuno to ask a question first. I think I hand up. I hand up before
okay, Ibitamuno, you can ask your question.
Okay, my question, based on the job of the data analyst, you said it's to search the internet. So is that all we're going to learn on the data analyst job? Just how to get data or search the internet for the data?
Oh, okay. Okay. So that is the primary responsibility of the data analyst. Now, what do you mean by search the data? They don't mean that you go and just look for data and analyze any data you find on the internet. They mean you have a voluminous amount of data, and then you search for the data that is reasonable to the course, to what you are planning to achieve. That is the primary key. Now, when a data analyst does that, that is the primary thing it does. And when a data analyst does that, so from there, it can now say, okay, I want to derive meaning from this data, and then I want to do analysis. Now, a data scientist also does analysis. It does analysis too, but then it recommends better ways, and it does more research than data analyst does. But a data analyst just sees a huge chunk of data and then extract the reasonable data. That is sourcing for the data he needs. Extract the reasonable data he needs, and then get meaning from it, and then could also analyze it. So on data analyst track, you are not only learning how to get the data you need, right? You're also learning how to analyze the data. Like you were told, you're going to be taught Hadoop, a lot of things. If you look at your curriculum, was your curriculum shared with you?
Yes.
Okay. So if you look at the curriculum, this is data analytics curriculum. If you look at the curriculum, you'll see that you have a whole lot. So you are also analyzing data as a big data analyst. You're going to be analyzing data, right? But then the primary responsibility of a big data analyst is to get relevant data, to source for relevant data. And then when you source for relevant data, then you can analyze your data. So no, you're going to be learning a lot more. You're even going to be learning some engineering aspects, because a big data analyst that has no idea of the engineering aspect might fall into big trouble, because there are sometimes you actually need to know some parts of the engineering because you don't always want to wait for Mr. Blessing said yesterday, right? He said you should not always wait for your big data engineer to come and help you achieve one 5-minute task that you would do and continue with your work. So what if your engineer is busy? So there are some things that you'll be learning that are more engineering related. You have an idea of them, but then a big data analyst should have an idea of most of big data technologies so that you don't get lost in between, right? So you're not just learning how to source for data, but that's the primary responsibility of big data analyst. He or she actually sources for the right data. And then from there, you could also do other things. But then that's the primary responsibility. That's why they said primary responsibility. They didn't say complete responsibility. So that's the primary responsibility of a big data analyst. So you're going to be learning a lot. Don't be scared. You're going to be learning a lot. Yeah. Any other questions? Hubert, you dropped your hand.
Yeah, sorry. What I wanted to ask, I think it's somehow answered. But basically, what I really wanted to ask was with regard to the question you asked. The question was on a marketing manager or the marketing head. Then the answer was behavioral analytics. So we didn't really cover that during this session. I don't think we covered that during the session. But I believe it's something that, like, repeating. It's something that we might learn as we progress. And the terminal mentioned about the curriculum. I was wondering, and I noticed you displayed it for a split of a second there. So I was wondering if it's possible for us to have access to the curriculum, so probably we could read ahead or stuff like that.
I thought you had the curriculum. Someone said you all had the curriculum, right?
I don't know if does anyone else have it, because I don't think I have it.
No, I don't.
So who said we have the curriculum?
No, we don't have it. It's just timetable we have, not curriculum.
Oh, not curriculum. Okay. So about that, I think it would be best to discuss with Mr. Blessing on the curriculum. So I do not know much about the organization. Giving you the timetable and all. I'm a trainer, and for that part, we would need to talk to either Temitope or Mr. Blessing. So if you are supposed to have the curriculum, you would have it. So I'm going to let them know that you requested for it. And then if you're supposed to have it, you're going to have it. And if not, I cannot do anything about it. Sorry. So I will talk to them, and then they'll probably inform you if or not you're supposed to have the curriculum. However, for Hubert's question about behavioral analytics, I know we all understand predictive analytics. We understand data interpretation. So behavioral analytics is just basically you are trying to drive business outcomes. You want to see what is happening in your business. You want to improve your customer satisfaction. You want to improve business costs. You don't want to spend so much on your business. You want to drive innovation. All of these things, you want to create new models. You want customers to buy your products more. That's behavioral analytics. You are trying to understand your business. You're trying to understand your customers. You're trying to see what customers love. That is behavioral analytics, okay? Predictive analytics is using what you have now to predict what you need, to forecast for what you need in the future. And then most times you use real-time analysis to predict for predictive analytics. So real-time data rather. So when data is coming in, as data is coming, you can easily predict that, okay, this is the amount of data that's going to come in tomorrow or in the future. So real-time data is used for predictive analysis. But behavioral analytics, most of the time, it is internal data. It is business data that you use, organizational data, which is internal data. That is what you use majorly for behavioral analytics. So you use what you have to understand your customers and then know what your customers want. And this in turn helps improve customer satisfaction, which in turn helps you get more profit in your business. So that is what behavioral analytics is about. And then data interpretation. I've explained that you can from understanding your data, you can know what product next to build, or what your customers want next, or how your customers now want it. That is interpreting your data. So I think I've explained that aspect now. Those are the analytical approaches. So I think that was what Hubert was asking me. So we didn't explain that part. I've answered your question, Hubert.
Yes, thank you very much.
Okay. All right.
Hello.
Any other thing? We've spent much of our time.
Okay, I'm trying to use the mouse, but I can't do it on mobile.
You're trying to do what?
It's up my hand, but I can't do it on mobile, so I don't know if I'm going.
Okay, you can go on.
Okay, to for data categorization.
Yeah, I'm here.
So the timetable, they're supposed to have the timetable, or since they don't have the timetable, like the curriculum, I'm going to get back to them on that.
Okay. So Emmanuel says he'll get back to all of us on curriculum. So I think we are good now. So Richard, you can go ahead.
Okay, I wanted to ask, to determine the data if it's big data or not. You said you have to check the elements, which are the velocity, variety, and volume. So for the volume is the quantity and the size. At what size are we going to say data is a big data? Is it maybe as the million or the billion? I need clarity on that.
Okay, at what size do we say data is big data?
In terms of the volume.
Okay, so big data can actually mean anything from 1 terabyte. So when you have data that is 1,000 from like 1,000 gig upwards, then you can call that big data. So it can mean anything from 1 terabyte upwards. So that is where you start having big data. When you start having 1,000 gig of data, and 1,000 gig of data is 1 terabyte, you can start saying, yes, I have started working with big data. So that is what I would say. Yeah. I think it's in your textbook somewhere. It should be in your textbook somewhere. If you check, I don't know. I've seen it somewhere. So yeah. Are we good?
Okay. Yeah. Thank you.
Okay. You're welcome.
Thank you very much.
Any other questions? No questions, right? Any other questions? Okay. All right. In the absence of no question, I'll ask Mr. Emmanuel if he has anything to say. Emmanuel, do you have anything to say?
Hello.
Emmanuel. Okay.
Yes, I'm
What did you say?
I said I'm with you.
Okay. Did you have anything to tell them before I dismiss the class? You said?
Anyway.
Do you have anything to say before I dismiss the class?
No, nothing. You can download the attendance sheet before you go.
Okay, so where do I download the attendance sheet from? Everybody stay online. We're trying to download the attendance sheet. So how do I do that, Manuel? Let me stop sharing my screen. So how do I do that, Manuel? Or can you do it?
I can just click on it. But this button inside the button, can you see the button inside the button?
This button. Copy join info. I actually cannot hear you, right?
The button beside the get button, that you can show participant.
Okay, yes.
So if you click on it, you see a kind of download button upward.
Copy join info.
Download attendance list either.
I'm coming. Let me see if that works. So it didn't work. I can't find download.
Don't worry, I'll do it from my hand.
Yeah, can you do it, please?
So
I don't think I can do it. I think you should be the only one that can do it. I can dismiss the class, right?
No,
Okay.
sorry, please. There's one of us whose name is showing as unknown user. I don't know if you can see his name.
Yeah, I can see him.
Yeah, hello. Good afternoon,
Who is that?
My name is Henry Osita. I've been on the class.
Okay.
I've been on the class with my phone, so it has been showing as an unknown user for a while. So I think I've told my colleagues I'll rectify that issue for the next class.
Okay, I think you skipped the part where you input your name before joining the class. I think that's where the problem is.
On my profile, it's showing my full name. I even have a picture there, but surprisingly, I don't know why it's still showing as an unknown user.
Okay, I think Emmanuel will take note of that. Just add.
There's been lingering for like the last 2 classes. So
okay.
I'm hopeful that before the next class it should rectify.
Okay.
Yeah.
Hopefully. So Emmanuel will take note of that.
Thank you very much.
Oh.
Thank you very much, Hubert.
Yeah.
No problem,
All right,
Henry.
in the absence of questions, the absence of questions, I will dismiss this meeting. Thank you everybody for coming and thank you for listening. I hope you learned something today. It was nice having this time.
Thank you so much.
Thank you very much.
Thank you.
Thank you very much, ma'am. Really enjoyed it.
Welcome. Thank you.
Bye, everyone. Bye, Henry.
Oh, she received you. You still have it.
Yeah, you too.